Hi, this is DIPJOY, and in this session I will guide you through creating an intermediate level PCG building system in Unreal Engine 5.6. We will cover setting up modular base floors and walls, managing wall corners for clean transitions, using splines to generate multiple building levels, creating adaptive roof that match the building footprint, customizing top floor walls and corner meshes, placing balconies on selected upper levels, and adding controlled randomness for variation. We will cover a lot of things. Let's begin. Since this is an intermediate PCG tutorial, I will be moving quickly, but I will still give you enough context so you can follow along. Here I have a basic level setup in Unreal. Go to the edit menu and open plugins. Search for PCG and make sure all the PCG plugins are turned on. If Unreal asks for a restart, simply restart the engine. Go to the content browser and create a new folder named Building. Inside that folder, create an actor blueprint and name it PCG Building. Drag and drop this blueprint into your level. Then double click it to open. Make sure drag and drop the blueprint actor into the level. Now in Blueprint, go to the component panel and add a PCG component. Select the PCG component under the graph section and choose PCG graph. Choose the folder where you want to save it. Name it PCG building graph and save. Then select create empty graph and hit compile. We add the PCG component inside a blueprint so the graph can generate a building and we can move, reuse and control it like one smart asset. Double click to open the PCG graph. Right click and type create point grid node. We use the point grid node to generate a clean grid of points that will define the shape and size of the building. Take a debug node, connect it and change the point mesh to axis tripod. Press A to inspect the points. In the viewport you can see grid of points. Now I will move these grid points to this actor position. So open the PCG graph. Take get actor data node to find the blueprint actor position and change the mode to get single point. Take copy points node. Grid points will be source and actor data will be target. Connect the debug node and inspect. Go back to the level, click force region to update the PCG. Now you can see the grid points move to blueprint actor's position. Now when I change the actor scale, you can see grid points also affected. I don't want that. So open the PCG graph. After using get actor data node, I will call transform points node to keep the scale at 1. I want these points to always have a scale of 1. So I will choose absolute scale. Click force region and save. Go back to the level, change the scale of this actor and see these points are not affected. Now I have to offset this ground point as per wall width. Go to PCG graph. The point grid generator node defines the building base by setting its width and height. I have downloaded some building and roof assets from QuickSellBridge. Go to QuickSellBridge and these building assets I have used for creating this build. I will share the list of assets in the description. Now select the building wall kit and see the size, which is width, thickness and height. Go inside the blueprint and create a variable, wall width. Change the type to float. Turn on instance editable. Now duplicate this variable in 2 times. Change the name wall thickness and wall height. Now select the class default and update this variable value. 350 instead of 49, write 50. Instead of 301, I will take 300 as we see on that wall thickness and height. Go to PCG graph. Grid cell size will be width of a wall. So I take the get actor property node and make sure it connected cell size. Change the property name to wall width. Click force region and save it. Inside in the level, you can see points are adjusted as per width. Go to PCG graph, we have adjusted the grid extent, which is building X and Y size. Go to blueprint, create a variable name building grid count X and set the variable type to integer. Compile and save. Turn on instance editable. Set the slider and value range from 3 to 25. Set default building grid count X to 3. Compile and save. Duplicate the variable. Change the name building grid count Y. And again compile and save. Now go to construction script. Here we can update all the PCG parameters. Press S to take a sequence node. Drag the PCG component and call get graph instance. I can promote it into a local variable so that I can use this graph variable easily. Rename the variable as graph instance. Take wall width and multiply with building grid count X. Duplicate this node and replace the building grid count X to building grid count Y. To control width and depth size, we create a variable named total wall size. Change the type to vector 2D. In this vector we are going to store building width and depth data. Now drag the variable and set it. Split the total wall size and connect X to X, Y to Y. Let me arrange these nodes. Compile and save. Go to PCG graph. In graph parameter section, create a new parameter named wall grid extent and set the type to vector. Now right click, type wall grid extent parameter and connect to grid extent in create points grid node. Now I will update this parameter inside the blueprint. From local variable, take a graph instance and set the vector parameter. Connect the execution pin. From PCG graph, copy the parameter name and paste it here. Split the value. Take the total wall size variable, split it, and X will be divided by 2. Y will be divided by 2 and connect to vector parameters X and Y. X and Y are divided by 2 to get the half size since building expand outward from the center, not from corner. Compile and save. Force region and save. Now go back to level, you will see a 3x3 grid of points. If I change the grid count for X and Y, points are updated instantly based on the new values. Go to PCG graph. Now take a static mesh spawner node. In mesh entries, select mesh. I am using the flat roof kit for the floor. Force region and save. You can see floor size doesn't match the wall width. To scale the floor, take a transform node before static mesh spawner. Create another parameter named floor scale and set the type to vector. Now right click, get floor scale and connect to the transform points scale min and max. Force region and save. Now go to blueprint and update this floor scale parameter. Copy the graph instance and vector parameter node. Connect the execution bin. Copy the parameter name and paste here. Roof kit size is 300. Duplicate the wall height variable and rename floor scale. To set and calculate the actual scale, wall width divided with floor scale, and connect to X and Y. Set the Z value to 1 so the flat mesh stayed visible. Setting it to 0, it would make it disappear. Now compile and save. Force region and save. In viewport, see, scale is updated. Inside PCG graph, inspect the floor scale 1167 on X and Y and Z is 1. If you inspect the transform node, you can see Z values is not updated. So check off the uniform scale, it will update here as well. Create another variable, name floor offset. In the level, you will notice the mesh axis is placed at the corner. I need the pivot at the center so the calculation work from the middle, not from the side. To PCG graph, change the parameter type to vector. Call the floor offset parameter and connect it transform points offset min and max. Let me arrange these nodes. Let's go to the blueprint and update this floor offset. Copy the graph instance and vector parameter node. Connect the execution pin. Go to PCG graph. Copy the parameter name and paste here. To place the pivot point at the center, I am offsetting X as negative and Y as positive and divide the wall width by 2. Take wall width divided by 2 and multiply by -1. Connect the negative value to X and positive value to Y. Compile and save. Force region and save. Now in the level you can see pivot correctly positioned at the center. Go to PCG graph. Select this node and comment them as floor. Select all these points generation nodes and comment them point grid gen. From copy points node, take the name reroute decoration node to make the graph clean. Change the name to point grid gen. Right click and take the point grid gen node, then connect to transform points node. Now everything works the same, but the graph is much cleaner. Let's create some walls. Right click and take the point grid gen node. Duplicate the static mesh spawner. Connect it to the point grid generator. And switch the roof mesh to wall kit. Then add a debug node to visualize the points. Inside in the level walls are placed, but I have to offset this. Now inside in PCG graph, take transform points node before static mesh spawner node. Select all the nodes and comment it right wall. Now create 4 parameters for the 4 walls and name them wall offset 1, 2, 3 and 4. And set each one type to vector. Right click and call wall offset 1 and connect 2 transform points offset min and max. Go to blueprint and update this wall offset 1. Select all the top floor nodes and comment them floor. Let me adjust this node so the graph looks cleaner. Copy the graph instance and parameter node. Connect the execution pin to sequence node. Go to PCG graph. Copy the parameter name wall offset 1 and paste here. It will move in y-axis. I will create a local variables for wall half width and negative wall half width since I will be using them repeatedly. Wall width divided by 2 promote to local variable, name the variable to wall half width and connect the execution pin. Now multiply this value with -1 and promote to local variable, name the variable and negative wall half width and connect the execution pin. Click compile and save and go to wall offset section. Take wall half width variable and connect it in Y as it's moving in Y axis. Click compile and save, force region and save. In viewport you can see walls update immediate. Go to PCG graph. Now duplicate all the top nodes, change the comment name to left wall. In transform points node, change the rotation min and max to 180 degree. I delete the top static mesh so that I can only focus on left wall. Force region and save. Here in the level you can see we offset the wall in negative. Go to blueprint, copy the graph instance and vector parameter, change the name to wall offset to connect negative wall halfway to Y. Force region and save. In viewport you can see walls are moving in negative Y direction. Go to PCG graph. Again duplicate all these top nodes. Change the comment name to back wall. In transform points node, change rotation min max to -90 degree. I delete the top static mesh so that I can only focus on back wall. In viewport you can see this axis is X. Now repeat the same steps and change the comment name to front wall and change the rotation min max to 90 degree. Force region and save. Go to blueprint, duplicate wall offset 1 and 2, connect the execution pin, change the name wall offset 3 and 4 as front and back in X axis, so I will shift both the connection to X. Compile and save. Go to PCG graph, force region and save. Go to PCG graph. Delete the extra static mesh spawner and connect all wall points to a single static mesh spawner. You will notice there are too many walls. I need only 4. So I will disconnect the extra connection. Now create a 4 difference node. One for the right minus left, one for left minus right, then front minus back and back minus front. Then use a merge point node and connect all 4 difference nodes to it. Now connect merge point node to static mesh spawner node, force region and save. In the level we have only 2 walls are showing. Back in PCG graph, the wall offset nodes were not updated. Replace them with wall offset 3 and wall offset 4 and the floor walls will appear correctly. In the level we have now 4 walls and we have to offset them. Add transform points node before static mesh spawner. Create a variable named wall offset adjust. Set the type to vector. Connect wall offset adjust parameter with transform points offset min and max. Force region and save. Connect the execution pin. Copy the name and paste here. Compile and save, force region and save. The walls are now updated perfectly. The walls are now perfectly aligned in the level. Next, add the wall thickness to the Y value. Compile and save, force region and save. This will create the corner gaps needed for the placing corner pillars. Now let's create the wall corner pillars. Take a point grid gen node. Then take a static mesh spawner node. Go to the mesh entries, select the pillars from wall kit. Disconnect the debug node and connect here to see the points. Force region and save. In the level you can see pillars are spawning. So here I have moved the pillars into this corner. So for that I have to offset the pillar on negative X and positive Y. Go to the PCG graph, create a parameter named corner offset 1. Change the type to vector. Actually I need 4 pillars. So create 3 more and name them corner offset 2, 3 and 4. And set each one's type to vector. Take a transform node before static mesh. Basically, we repeat the same steps as we did for the walls. Call corner offset 1, connect it into transform points offset min and max. Force region and save. Go to blueprint, select all the top nodes and comment them walls. Now copy the graph instance and set vector parameter node. Create another execution pin on sequence node and connect to set vector parameter. Arrange the nodes. Go to PCG graph, copy the parameter name and paste it here. So here I need to move the pillars into this corner. To place it correctly, I am going to offset the pillar along with negative X and positive Y. I am dragging the local variables and connecting wall halfway to the Y value and negative wall halfway to the X value. Compile and save, force region and save. In the level you can see pillar shifted to the corner. In the PCG graph, duplicate the nodes and switch the parameter to corner offset 2. Set the transform min max to 90. Then disconnect and hook the static mesh to this pillar setup. Force region and save. Now go to the level and see now I have to offset both X and Y to negative. Go to blueprint, copy the graph instance and set the vector parameter node. change the name to corner offset 2. I'm dragging the local variables and connecting negative wall half width to the x and y value. Compile and save. Force region and save. In the level you can see pillars are shifted to the corner. Again repeat the same task, duplicate the node and switch the parameter to corner offset 3. Set transform min max to 180, then disconnect and hook the static mesh to this pillar setup. Force region and save. In this blueprint, copy the graph instance and set vector parameter node. Change the name corner offset 3. Compile and save. Now in the level, see I have to offset the pillars on negative y and positive x. I'm dragging the local variable negative wall half width to the y value and connecting wall half width to the x. Compile and save. Force region and save. In the level you can see pillars are shifted to the corner. Again repeat the same steps, copy the graph instance and set vector parameter node. In the PCG graph, duplicate the nodes, set transform min max to -90, then disconnect and hook the static mesh spawner to the pillar setup. Force region and save. In the level it's not updating. Go to PCG graph and switch the parameter corner offset 3 to corner offset 4. Force region and save. Now in the level C, I have to offset both x and y into positive. I am dragging the local variables and connecting wall half width to the x and y value. Change the name corner offset 4. Compile and save. Force region and save. In the level you can see pillars are shifted to the corner. Inside the PCG graph, connect all the transform points node to the static mesh spawner node. In the level you will notice there are too many pillars. I need only 4. So I will disconnect the extra connections. Repeat the same thing as we did for the walls. Create 4 different nodes. One for the right minus left, one for left minus right, then front minus back and back minus front. Then use a merge point node and connect all 4 different nodes to it. Now connect the static merge spawner node. In the level you will notice there are too many pillars. I need only 4. So I will disconnect the extra connections, merge them left and right corners, then merge the front and back corners. Now I will take 2 different nodes, one for top minus bottom and another for bottom minus top. Then use a merge point node and connect this difference node to it. Now connect a merge point node to static mesh spawner node. Force region and save. Go to the level, see we have now 4 corner pillars. For better placement, I have to offset these pillars. Go to the PCG graph, create a parameter named corner offset edges and set the type to vector. Let's make some room. Take a transform point node before static mesh spawner. Call the corner offset adjust parameter and connect 2 transform points offset min and max. Force region and save it. On level, it's not updated. Go to the blueprint, copy the graph instance and set vector parameter node. From the PCG graph, copy the parameter name and paste it here. For the placement, you can see on the level, I have to take wall thickness on Y positive and negative on X. So I will take wall thickness multiply by -1. Connect 1 minus to x and positive to y. Compile and save. Force region and save it. Go to the level. You can see corner pillars are placed correctly. Now select all the pillars creation node and comment them corners. Now place them under the wall section. Go to the wall section. From transform points, I will take a copy points node. Connect the transform points out to copy points target, and the source need a point. So take a create point node and connect it to source. If I inspect it, it will show 1 points, and if I inspect the copy points, it will show 12 points. If I want to another floor, I want to create another point and take merge point node to connect the both points. Connect the merge point out to copy point source. If inspect the copy point, it will show 24 points. Force region and save. Go to the level and see nothing change. These 2 points are same, so these walls are overlapping. In the PCG graph, on the second create point node, add a transform point node to offset the point. Since the wall height is 300, set both offset min max to 300. Force region and save. Go back to the level. As you can see, we now have a second floor generated automatically. Now if I want another floor, I just duplicate this node and set the transform point to 600. Force region and save. And as you can see in the viewport, we get another floor. But hard coding it like this is not practical. Make some room, arrange these nodes. Create a new parameter named last wall point adjust and set the parameter type to vector. And connect the parameter to transform point offset min and max. Make some room, arrange this node. Now I have to update the parameter inside the blueprint. Go to blueprint, select all the top nodes and comment them corners. Add a pin to sequence node, copy the graph, instance and set the vector parameter node. Connect the sequence execution pin to set vector parameter node. Go to PCG graph, copy the parameter name and paste it here. In the variable section, duplicate the variable building grid count x and rename it to number of floors. Go to the top where we set our local variables. Take wall height and multiply with the number of floors. Each wall is 300 units tall, so if I set the number of floors to 3, the total wall height becomes 300 into 3 equal to 900. Promote the local variable and give a name building wall height. Connect the execution pin, compile and save. To calculate the parameters, subtract the wall height from the total building height. If the building height is 900 and one wall height is 300, then 900 minus 300 gives 600 height for the remaining 3 floors. Subtract the building wall height to wall height and connect it to Z as Z for the height. Force region and save. In the level you can see we have 2 points. First point is on the ground and second point shifted to third floor. If increase the floor count, you can see the last point shifted upwards. There are no points in between to build the floors, so we need to generate them. In the PCG graph, disconnect the merge point node and create a spline to generate in between points. Set the spline point to linear for a straight line, then add a spline sampler node. Set its mode to distance and use wall height 300 as the sampling distance. From the distance increment pin, add a get actor property node and set the property name to wall height. Also make sure unbound is enabled on the spline sampler node. Now connect the output to the spline sampler node to the copy point source and compile and save. Go to the level, you will see mesh are not oriented properly. Go to the PCG graph, select the copy points node, change the rotation inheritance to target. It will correct the rotation, but corner does not appear on the top floor. Let's fix it. Go to PCG graph, disconnect the spline sampler node and take name readout declaration node. Press F2 to rename it Spline's floor level. Disconnect the transform point node and take the name readout declaration node. Press F2 and rename wall points. Now right click, take spline floor level node. Then take wall points node. Now everything looking much more organized. Select all the nodes and commit them wall gen. Then duplicate all the nodes and rename it corners. Now go to the corner section, disconnect the static mesh spawner node, take the name readout declaration node. Press F2 to rename it corner points. Now take this static mesh spawner node on the top which contains corner pillars. Delete the static mesh node, connect this static mesh which contain pillars and change the node wall points to corner points. Force region and save. Now go to the level. You will see corner aligns perfectly. If you want to floor on each level, you also can do that. By using Spline, we can generate floors also. Go to the PCG graph. Copy the copy points node. Go to the floor section. Paste the copy point node. Take a spline 4 level node and connect to source and transform points out will be target and connect it before static mesh spawner node. Force region and save. Go to the level. Now you can see floor on each level. I don't want to set up this right now, so I will disconnect it. Go to PCG graph. Now I am going to change the base floor. For that I am going to delete the base floor. Go floor spline section. Make some room, arrange these nodes. Copy the transform points node and connect it to the first create point node like so. Create a parameter named first wall point adjust and set the type to vector. Now call the parameter and connect to transform points offset min and max. Make some room, arrange these nodes. Now go to the blueprint, copy the graph instance and set the vector parameter node. Go to PCG graph, copy the parameter name and paste it here. Connect the execution pin and connect the wall height to Z. It will delete the base floor. Compile and save. Force region and save. In the level you can see base floor is deleted. Now go to the PCG graph. Take wall points node and duplicate the static mesh spawner node and then change the mesh to building base door kit. I select this mesh. Select the both node and comment them base wall. Force region and save. Go to level. Here is our base wall. Duplicate the base wall section. Rename it wall corners. Change the wall point to corner points. Force region and save. Select the static mesh spawner. Go to the mesh entries. And from building base wall kit, I take these corner pillars. Go to the level and see the corner appears perfectly. Now I will add some base trim parts. Go to the PCG graph. Duplicate the base wall. Rename it base trim. Select the static mesh spawner, go to the mesh entries and select the base trim from the building base trim kit. Force region and save, go to the level, see trim parts are here. Now I have to offset them on top. Take a transform points node before static mesh spawner. Create a parameter named base trim adjust. Call the base trim adjust parameter and connect to transform points offset min and max. Now let's update the parameter in the blueprint. Marquee select the previous node and duplicate here. See the building base door kit size. Height is 268, so I will take approx 250. Create a new variable named base wall height and set the value to 250. So delete the wall height and take base wall height and connect it to Z. Copy the parameter name from PCG graph and paste it here. Compile and save, force region and save. Go to the level, you can see trim parts are placed on top of the base wall. Now for the corners, we do the same thing. Go to the PCG graph, duplicate the base trim, rename it base trim corner. Change the wall point to corner points. Go to static mesh spawner and select the mesh from base trim kit. I use this mesh. Force region and save. Go to the level, you can see corners are now placed perfectly. Duplicate the base trim and rename it roof trim. Create a parameter called roof trim adjust and change the type to vector. And connect it transform points offset min and max. Select a static mesh spawner node and switch the mesh to building roof trim kit. I'm using this mesh here, force region and save. In the level you will see roof trim is sitting at the bottom of the building. We need to offset it upwards so it appears at the top. In the blueprint, duplicate the graph instance and set the vector parameter node. Connect the execution pin, delete the base height variable and connect the building wall height variable. Copy the parameter name and paste it here. Compile and save, force region and save. Go to the level, you can see roof trim parts are placed on the top. Now we need the roof trim corners. In the PCG graph, copy the roof trim setup, paste it and rename it roof trim corners. Change the input from wall points to corner points. Then select the corner mesh. In the static mesh section, force region and save. In the level, corners appears but not orient correctly. So set the transform points rotation min max to 90 degree. Go back to the level, you will see the rotation is fixed and the roof trim corners are placed perfectly. Go back to PCG graph, duplicate the roof trim corner section and rename it roof corner. Create a parameter called roof corner adjust. Change the type to vector. Right click, call roof corner adjust parameter and change it to transform points offset min and max. Go to the blueprint, duplicate the graph instance and set the vector parameter name. Connect the execution pin, then copy paste the parameter name to here. I'm using the same building height value to place the roof corner. Mesh doesn't appear. Go to the PCG graph, select the static mesh spawner and switch the correct mesh. I'm using this mesh. The corners are slightly low, so I need to move them up. In the blueprint, create a variable called roof trim height. Make it instance editable. Set it to 20. Add this value to the building wall height and plug it into the Z offset. This raises the corners by 20 units. In the level, you will see corners are perfectly adjusted. Now we will be creating the remaining parts of the roof. Inside PCG graph, duplicate these nodes except static mesh spawner. Take a debug node, Connected transform points and set the point mesh type to axis tripod. Force region and save. Now go to the level. You can see axis appears on the roof corners. Go to blueprint, select all the top nodes and comment them roof and base. Go to PCG graph. Now I have to disable the roof trim. My bad. This is base trim. Now disable the roof trim so you can see the axis clearly. Now I have to move this axis to here so that I can calculate this gap and fill it out. Go to PCG graph, take a transform point node. Create a parameter named roof corner pivot adjust. Call the parameter and connect to transform points offset min and max. Force region and save. Now go to blueprint, copy the graph instance and set vector parameter node. Create an execution pin in sequence node and connect it to the set vector parameter node. Arrange these nodes. Copy the parameter name from PCG graph and paste it here. Now duplicate the roof trim height variable and rename it roof corner width. So here corner width is 507. I will take only 500. Now take the roof corner width, multiply by -1 and connect it to the axis where the offset needed, in this case the y-axis. Go to PCG graph, disconnect the debug node and connect it to the transform point, force regenerate and save. In the level you will see the pivot correctly adjusted. Now select the PCG building blueprint and set the building grid count to X so that we can measure the space horizontally and vertically. To calculate the spacing between roof element, first I need the building size. In the blueprint, duplicate the total wall size variable and rename it total building size. So here actual building size will be 3 walls and 2 wall thickness. In the blueprint, go to the local variable section and set the total building size. Split its pin, then its total wall size as well. Multiply the wall thickness by 2 and add this to total wall size. Connect X to X, Y to Y and hook up the execution pin. Go to the bottom, disconnect the nodes and reconnect it after roof corner adjustments. So all the roof corner adjustments stay together in one place. Hit compile and save. Take a total building size variable, split it. Now create two more local variables named building space vertical and building space horizontal. We have to set this variable. Take a roof space vertical and connect it with sequence node execution pin. Take the roof space horizontal. For calculate the space, I have to take total building size and to two corner width. Now take the roof corner width, multiply by 2. Now take the roof corner width, multiply by 2. Subtract it to total building size. Connect to X, Y to Y and hook up the execution pin. Now here in the gap, I need to create a spline to create points. We already have a spline, we reuse them as a subgraph. Go to the spline floor level section, disconnect them from the name declaration node. Select all the nodes and select collapse to subgraph. Then select the folder where you want to save and rename it building subgraph. Now double click to open the subgraph. Take the output node and connect it after spline sampler. Change the output type to point. On the parameter section, I will move up the first point so that it looks visually well. Take a parameter named step distance, type will be float, set the value to 100. If you leave this value 0, Unreal will crash. Call the step distance parameter and connect it to the distance increment. Force region and save. Then cut the actor property node, paste it outside the subgraph and connect it to the subgraph's step distance pin. Now connect the spline floor level node to the subgraph node. If you inspect this, it will show the values. Go to the subgraph, select the output node, click graph setting and set expose to library. Now in the PCG graph, go to the section where we adjusted roof corner pivot, right click and call building subgraph. Create a parameter named last roof horizontal. Set the type to vector. Here first wall will be 0. I did not do anything And for the last one, I will add the parameter called last roof horizontal. For step distance, I will add the roof width. So here is roof width 51, I will take 50. Go to the blueprint, create a variable name roof width. Set the value to 50. Get actor property. Go back to PCG graph from the step distance node, call get actor property node and change the property name to roof width. Now take a copy points node, transform points will be target and subgraph output will be source. If you inspect this node, you can see values are here. Now I have to update this last roof horizontal parameter inside blueprint. Copy the graph instance and set vector parameter node. Connect the execution pin. Copy the parameter name from PCG graph and paste it here. Now take the building space horizontal variable. I need points on this y-axis. So building space horizontal multiply with -1 and connect it to in y-axis. So building space horizontal multiply with 1 and connect it in y value. Compile and save. To see the points, go to PCG graph, take a debug node after copy points. And set the scale method to absolute. And change the point mesh type to axis tripod. And set the point scale to 0.5. Force region and save. Go back to level, you can see points are appearing here. Now go to the PCG graph and take a static mesh spawner node. Go to the mesh entries and select this mesh, force region and save. Go to the level and see roof caps are filled perfectly. Over here you can see I have an extra roof here. I have to subtract it. Go to the blueprint, take a building space horizontal minus roof width and then multiply with -1 and connect the value in y value. Go to the level, see we can fix this issue. Make sure save the progress as well. Go back to PCG graph, disconnect the corner points node. As we inspect this node, you can see we have 4 points. Focus on the rotation yaw, 180, -90, 0 and 90. Take a ABS node, connect it to corner points, select the input source. From the point to rotation, I am focusing this yaw. So rotation dot yaw, output target is ABS yaw. Here point filter is added to separate the vertical and horizontal points. Set the operator to equal. Set the target absolute to ABSO. Use constant threshold and double value to 90. Use constant threshold means we compare the point to fixed a value instead of another point, and double value 90 means we are checking if the yaw equals to 90. Now duplicate these nodes, select the top nodes and comment them as horizontal roof. Select all the bottom nodes and comment them as vertical roof. Create a parameter named last roof vertical and set the type to vector. Now call the last roof vertical parameter and connect with the last wall point. Adjust the subgraph in the vertical roof section. Delete the horizontal one. Now go to the blueprint, copy the graph instance and set the vector parameter node. Copy the parameter name, paste it here. Select all the previous variable and connect to Y and replace the last roof horizontal variable to last roof vertical. Compile and save. Compile and save. Go to the PCG graph. From point filters, connect inside points to horizontal and outside point to vertical. Force region and save. Go back to the level and you can see we have now roofs. If you adjust the building height or width or depth, you can see roofs are adjusting accordingly. Here you can see building and roof logic working perfectly. Now I'm going to fill this hole on the top. For that I need building total height data and this building actor's position. Copy the get actor data and transform points node from the points grid section. Now take another transform points node and connect it after transform points node. Create a parameter named roof top height adjust. Call the rooftop height adjust parameter and connect it with transform points offset min and max. Now take the debug node and change the point type to axis tripod, scale method to absolute and point scale to 4. So you can see I have the axis here. I will delete the other axis nodes so that I can see the axis clearly. Now in the blueprint, go to the top side. Here we calculate the building height. In the local variable section, create a variable named building height and hit compile. Now drag the variable to set the building height. Take the building height, roof trim height, and we need roof height as well. Here roof height is 551. I will take 550. So in the variable section, I create a variable named roof height and set the value to 550. Now take the roof height variable as well and add them building height, then roof trim height, then roof height, and connect to building size and connect the execution pin. Now copy the graph instance and set vector parameter node, connect the execution node. Now copy the parameter name and paste it. Connect the building height to variable z. Compile and save, force region and save. Now on the level you can see access placed on the top of the building. Save the progress. Go to the PCG graph, select these nodes and comment them as rooftop adjust. From transform points, take a static mesh spawner node, go to the mesh entries and select the flat roof kit. And I use this mesh. Force region and save. You can see top part placed here. Now I have to scale this down to fit this part. Take a transform node before static mesh spawner node and create a parameter named roof top scale adjust. Now call the roof top scale adjust node and connect to transform points scale min and scale max. Go to the blueprint, copy the graph instance and set vector parameter node, connect the execution pin. Copy the parameter name and paste it here. On the variable section, create a variable named rooftop size and the size is 300. Take the building space vertical divided by rooftop size. Set the rooftop size to 300. Now connect it to X. Duplicate these nodes. Replace building space vertical with building space horizontal. Set the Z value to 1 or else it may disappear. Back to the level, scale is adjusted. Now we have to move the mesh to the center so that it can fill the gap. Go to PCG graph, take another transform points node before static mesh. Create a parameter name roof call offset adjust. Set the type to vector. Call the rooftop adjust parameter and connect to transform points offset min and max. Now go to the blueprint and update this parameter. Now copy the graph instance and set the vector parameter node. Connect the execution. Now copy the parameter name and paste it here. So in the level you will see width will be half of the roof, x will go negative and y positive. Take building space vertical node, divide it by 2 and multiply by -1. Connect it to x. Take building space horizontal node, divided by 2 and connect it to y. Compile and save. Set the z value to 0. Compile and save. Force region and save. Now go to the level. You can see wall top parts are fit perfectly. Let's change the count to x and y and see if that roof is working or not. Go to PCG graph, enable the roof trim parts. So here I have building with 3 floors and complete roof. Just go to the PCG graph and delete all the debug nodes so it will look much cleaner. Now I'm going to change the top floor walls. Go to the blueprint, go to the top section where we calculate the building wall height. I have to see what is the height of the top wall. It's 150. Create a variable name top wall height. Make it instance editable. Compile and save and set the value to 150. Take the top wall height and add to the building wall height. And from number of floors -1 floor and connect to multiply. Compile and save. Now go to the roof and base section, find the parameter last wall point adjust, which is top point. Click the plus pin and subtract and connect the top wall height. Compile and save, force region and save. Go to the level, you can see top floor is deleted. Now go to the PCG graph, copy the base wall section and rename it to top wall. Select the static mesh and go to the mesh entries and change the mesh to this wall. Force region and save. Go back to the level, you can see top floor placed on bottom. So take a transform points node before static mesh spawner. Create a parameter named top floor height, set the type to vector, call the top floor height parameter and connect it to transform points offset min and max. Force region and save. Jump to blueprint to update this parameter. In the blueprint, copy the graph instance and set vector parameter node. Select all the top nodes and comment them roof to. Change the roof base to roof corner and base. And change to roof horizontal and vertical. Create an execution pin on sequence node and connect it to the set vector parameter node. Copy the parameter name and paste here. Now take the building wall height and subtract with total wall height and connect on Z. Compile and save, force region and save. It's not updated on level. Let's see what we left. Yes, by mistake I take wall half width. We have to take building wall height. Building wall height will be subtracted with total wall height. Compile and save, force region and save, go to the level. See, walls are updated as expected. Now let's create corners for the top floor. Go to the PCG graph, copy the top wall section, replace the wall points to corner points, select the static mesh spawner, go to the mesh entries, change the mesh, and I select the pillar from this wall kit. Now you can see we have a building of 3 floors with each level have a separate walls. Move these nodes to make some room. We will create arrays in this wall so that we can create randomness on wall. Go to the blueprint, inside the variable section, create a variable named base wall variation and set the type to static mesh. Soft reference, right click to change the type to array, make it instance editable, compile and save. In the detail panel, click 3 times. Here I will add 3 mesh. Duplicate the variable and rename it mid-wall variation. Compile and save. In the detail panel, replace and add 3 wall mesh. Go back to PCG graph. Here in the base wall section, call get actor property node. Copy the variable name from blueprint and paste in its properties name. Take match and set attribute node and connect it before static mesh node. On get actor property node, set the output attribute name to mesh. Select the static mesh spawner node and mesh selector type, set PCG mesh selected by attribute. Here also give attribute name to mesh. Disable the wall gen static mesh to see that it's the mid wall. So I will copy the get actor property. And match set attribute node. Change the property name. Copy from blueprint, paste it here. Select the static mesh spawner and mesh selector type to PCG mesh selected by attributes. Here also give attribute name to mesh. Well, you can see I have random wall on base and mid floor. Save the progress. Now we will create some balconies on the mid level. Copy the wall section and rename it balcony. I will delete the actor property match and set attribute node. Connect the copy points node to static mesh and reset the mesh selector type. Go to mesh entries and select a balcony. Force region and save. Go to the level, you can see balconies appear on mid floor, but these balconies are not set up properly. Take a transform points node before static mesh spawner node and I will hard code the value of offset min and max. Force region and save. Go to the level, you can see balconies are placed perfectly. If you want randomness in placing balconies, then take an attribute noise node, density filter node, and take debug node and set the scale method to absolute point scale is 2, force region and save. Go to the level, you can see variation in placing balconies. You can adjust upper bound, lower bound as you want. Delete the debug node and connect it to static mesh spawner node. Now see, I have few placed balconies. Now if change the building position, it will completely different wall setup and balconies. Now if you change the building position, it will create a complete different wall setup and balconies. I want randomness on building 2. Go to the building, find the sequence node, right click and choose insert execution pin before. Now I create a variable named random building. Force region and save. Change the type to boolean. Make it instance editable. Compile and save. Set the random building value to true. Set the random building value to 2. Take a branch node. Random building is condition. Take the building grid X variable and set it. Same for the building grid count Y and number of floors. Now take a random integer range, give some random range, connect the building grid X, repeat these steps for building Y and number of floors. Select all the random nodes and comment them building random. Compile and save. I am moving this variable to the top so that I can access it more easily. Go back to the level. As I am moving the building, it randomly changes its sizes. Go to PCG graph, disable attribute noise and density filter. I don't need them now. We covered a lot today and I hope you gained some solid techniques. Keep practicing, keep experimenting, and I will see you in the next tutorial. I am excited to see what you create next. Until then, happy developing.